Hey everyone, it's me, Dr. V, and I'm here to do some AP Chemistry exam review. In this webcast, we're going to work through free response question number 5 from the 2024 exam. Now, the 2025 exam isn't that far away from when I'm recording this webcast, and there are some changes coming in May of 2025 that you should know about. First big change is that this year's exam will be a hybrid exam, and that means the multiple choice questions will be done completely online using the Blue Book app. The free response questions will be provided to you online, but you'll actually write your answers on paper in an answer book, and any diagrams or images that you'll need will be included in there. Some other things to be aware of: you will have a paper periodic table for the entire test. You'll have scratch paper for the multiple choice portion of the exam. The reference sheet, however, will only be available digitally in the Blue Book app. You'll have to pull it down anytime you want to look anything up, equations or constants, anything like that. You'll also have access to the online Desmos graphing calculator, and you'll also have the use of your own handheld calculator, whichever you prefer, whichever makes more sense for you. In terms of this webcast, we're working through free response question number 5, which was one of the 4 short free response questions in any AP exam. That means it's scored out of 4 points, and these short free response questions tend to have 3 or 4 parts to them. What I recommend that you do is you grab your calculator, your periodic table, your formula sheet, and some paper to write down your work, because what I want you to do is to let me set up each part of the problem and then pause the webcast, try to answer it on your own before you listen to my explanation, and then keep track of your score as you go. Did you earn the point for each part or not? All right, let's jump right into the problem. Hydrogen gas and iodine gas react to form hydrogen iodide at an elevated temperature, as represented by the following equation. Write the expression for the equilibrium constant Kc for this reaction. Now, AP Chemistry students need to be able to write equilibrium constants. In case you don't remember, here are simplified rules. You do products over the reactants, your coefficients become exponents, you omit pure solids and liquids. Now, they did specifically ask for a Kc, so this is all in terms of molarities or concentrations. Here's what you need to write: Hi squared over H2 times I2. As I mentioned, it is a Kc expression, so you should be using square brackets to represent molarity. This is different from a Kp expression, which is in terms of gas pressures, and you do need to make sure you write a Kc expression and not a Kp expression. That's what you needed to do to earn the 1 point for part A. Hydrogen gas and iodine gas are added to a previously evacuated container and allowed to react. At a certain time, the value of the reaction quotient Q is 0.67. The following particle diagram is an incomplete representation of the system at this time. The diagram shows the relative number of hydrogen molecules and iodine molecules, but the hydrogen iodide molecules are not included. Draw the number of Hi molecules needed to complete the diagram so that it accurately represents the system. To do this, we need to remember that Q takes the same mathematical form as K. It's just that we're not at equilibrium yet, so the value of Q can change. At this moment, Q is 0.67. Now, the other thing to keep in mind is anytime you see particle level models, always count your particles. What we see here, based on the key, is we have 2 iodine molecules and 3 hydrogen molecules. We can rearrange our Q expression to solve for the molarity of Hi. So I'm going to make an assumption here. I'm just going to assume that this is a 1 liter container and the number of particles are equivalent to a mole, because otherwise this doesn't make a whole lot of sense. It's how we often do this. And I can substitute in. I know what Q is. I know the number of iodine molecules. I know the number of hydrogen molecules. I can solve for Hi. And when I substitute Q and H2 and I2 in, I get a value of 2 for Hi. So I need to have 2 molecules of Hi, and that's what I'm going to draw. That's what you needed to do to earn the 1 point. Now, you didn't necessarily have to show all the work to get to figuring out that you needed to. However, you really do need to do that in order to figure it out. A student monitors the number of moles of Hi over time. Hypothesize an experimental change that could have been applied to the system in the rigid container at time t to result in the change in the number of moles of Hi shown in the graph. Assume that the student did not add more Hi to the system. So we know the balanced equation, and we've got this graph. We see at time 0, I didn't have any Hi. The moles of Hi increased and leveled off, meaning I reached equilibrium. And then at time t, we did something, and the moles of Hi increased. Now, the Hi is a product in the balanced equation. So what we're really trying to say here is that whatever the stress was on the system, it caused the system to shift right. I made more product. I made more Hi. Right? We shifted to the right. We had been at equilibrium, and now we've got a shift. So what we need to do is come up with a stress that we can impose on the system that would cause a shift to the right. There are actually three options. Any one of these would be fine. So I could add more hydrogen gas, I could add more iodine gas, or if I look up the equation, we know that this reaction is exothermic. We have a negative value for delta H. So my other option would be that I could lower the temperature. So I needed to just state one of these to earn the point for B part 2. After equilibrium is established, the mixture is transferred to a larger container at constant temperature. As a result, will the number of moles of hydrogen iodide increase, decrease, or remain the same? Justify your answer. Well, with these kinds of questions, you really want to make sure you lead with your claim and then back it up. What's helpful to remember here is we are at equilibrium, so Q and K are equal to each other, whatever the value of K is. We don't actually know the value of K, but we do know this balanced equation. What I notice right away is that I have equal numbers of moles of gas for reactants and products, and that's really the key to answering this question. I'm making the claim that the moles of HI would remain the same if we increase the volume of the container. Why? As I just said, the total moles of gaseous reactants and total moles of gaseous products are the same. There's no advantage one way or the other by shifting to one side or the other. Their concentrations of the reactants and the products would actually be affected equally, so there wouldn't be a shift in the equilibrium position. Now, there is another way to back this up using a Q versus K argument. So if we assume, for example, that the volume doubled, we just know that it's larger, but let's just assume it doubled. In that case, all the concentrations would be halved because of my initial stress compared to what they were at equilibrium. So if I think about Q, my concentration of HI would be half of what it was originally. My hydrogen concentration would be half of what it was originally. My iodine concentration would be half of what it was originally. So when I substitute this into Q, Q still equals K because everything cancels out. There's no shift in the equilibrium position. Either way, this is what I needed to argue to earn the 1 point. I needed to have a correct claim that the moles would stay the same and back it up in an appropriate way. So how did you do? The average score on this question in 2024 was 2.07 points out of 4, so just about 2 points. So if you earn 2 points, you're right on track. 3 or 4 points, you're doing well. If you didn't get the score that you wanted, you do want to make sure you go back and review those core ideas of equilibrium, LeChatelier's principle, writing KEQ expressions, Q versus K. All important things. If you found this video to be helpful, like it and leave a comment, and remember to subscribe to my channel so you get all my latest updates. Have a great day and keep studying chemistry.